Using identities, evaluate. This is 71 squared. Now this 71 squared can be written in the form of 70 plus 1 whole square, right? Now you can use standard identity 1 that says a plus b whole squared is equal to a squared plus 2ab plus b squared. Now here, take this as a, this as b, then a squared is 70 squared plus 2ab is 2 multiplied by 70 multiplied by 1 plus b squared means 1 squared. If you solve this, you get 4900 plus this is 140 plus 1. If you further solve this, you get 4900, then 5041. So this is your answer. This is the evaluation of 71 squared using identities. Now this is 99 squared. You can rewrite this as 100 minus 1 squared, right? You have to evaluate using identities, and we know 3 standard identities and 1 general identity. Now in this case, this should remind you of the standard identity number 2 that says a minus b whole squared is equal to a squared minus 2ab plus b squared. So this, in this one, you can take this as a and this as b. So a squared means 100 squared minus 2ab means 2 times 100 multiplied by 1 plus b squared means 1 squared. From here you get 10,000 minus 200 plus 1. So this gives you 800 plus 1, that is 801. This is the evaluation of 99 squared. This is 102 squared. Now this 102 squared can be written as 100 plus 2 whole squared. Now this should remind you of the standard identity number 1 that says a plus b whole squared is equal to a squared plus 2ab plus b squared. So if you take this as a and this as b, then this is a squared means 100 squared plus 2 times ab is 2 multiplied by 100 multiplied by b plus b squared means 2 squared. So if you solve this, you get 10,000 plus 2 times 100 is 200 times 2 is 400 plus 4. So this is 10,404. Now, in this case, you have 998 squared. This can be rewritten as 1000 minus 2 whole square. Now, this should remind you of the standard identity number 2, that is a minus b whole square is equal to a squared minus 2ab plus b squared, right? So take this as a, this as b. A squared means what? A squared is 1000 squared, right? Then minus 2 multiplied by 1000 multiplied by 2 plus 2 squared. So from here you get 1, 2, 3, 4, 5 and 6 zeros, and then minus 4000 plus 4, right? So this is actually 1, 2 means this is 10 lakh, right? So this is 9,96,000 plus 4, that is 9,96,004. This is your answer. This is 5.2 whole squared. Now this can be written as 5 plus 0.2 whole squared, right? 5 plus 0.2 is 5.2 whole squared. Now take this as a, this as b. So a squared plus b squared, a plus b whole squared means a squared, that is 5 squared, plus 2ab means 2 times 5 multiplied by 0.2, then 0.2 squared. From here you get 25 plus 2 times 5 is 10, 10 multiplied by 0.2 is 2, right? Now here you have 0.2 squared, it means that it is 0.04, and from here you get 27.04. This is 297 multiplied by 303. Now this 297 can be written as 300 minus 3, and this 303 can be written as 300 plus 3. Now if you remember, the standard identity number 3 says that a plus b multiplied by a minus b is equal to a squared minus b squared, right? So if you look at this one, we can write this as 300 plus 3 multiplied by 300 minus 3, right? And here if you take this as a, this as b, right, and this again as a and this as b, so it's of the form a plus b multiplied by a minus b, and we have written this expression in this form using commutative property of multiplication that states that if a multiplied by b, then this is equal to b multiplied by a. Okay, so this is a plus b multiplied by a minus b. This should be equal to a squared minus b squared. So what's a here? A is 300, so 300 squared minus b squared means 3 squared. This is 900, sorry, this is 90,000, and this is minus 9. This is 90,000 minus 9. This is equal to 8,991. This is 78 multiplied by 82. So this can be written as 80 minus 2 multiplied by 80 plus 2, right? Now this is of the form a minus b, a plus b, right? So if we write this expression as 80 plus 2 multiplied by 80 minus 2, how? Using commutative property of multiplication. So here it is a plus b multiplied by a minus b, and this should be equal to a squared minus b squared using standard identity number 3. So from here, this 80 a squared means what? 80 squared minus b squared means what? 2 squared. So this is 6400 and minus 4. 6400 minus 4. So this is 6,396. This is your answer. Here this is 8.9 squared. This can be written as 9.9 minus 0.1 whole squared, and this should remind you of the standard identity number 2, that is a minus b whole squared is equal to a squared minus 2ab plus b squared, and this is equal to, if you take this as a and this as b, this is 9 squared minus 2, 9 multiplied by b plus 0.1 whole square, right? This is 81 minus 2 times 9 is 18, 18 multiplied by 0.1 is 1.8, and this is plus 0.01. If you solve this, you will get 79.21. Again, this is 10.5 multiplied by 9.5. Write this 10.5 as 10 plus 0.5 multiplied by 10 minus 0.5. This is of the form a plus b multiplied by a minus b, right? A plus b multiplied by a minus b. So this should be equal to a plus b multiplied by a minus b. This should be equal to a squared minus b squared, standard identity number 3. So from here you get a squared means 10 squared minus b squared means 0.5 squared. From 10 squared you get 100 minus 0.5 squared means you get 0.25. Now if you solve this, you will get 99.75. This is your answer.